So today we're talking about probability again. This time we're going to use predicted probability to answer questions. Oh, I'm sorry. Actually, it's going to be called experimental probability to make predictions. Let me say that the right way. Yeah, we're using experimental probability, which means not theoretical probability, not what it's supposed to be, but we actually do an experiment, get some data, use that to answer questions. That's basically what I said, but I just said it in a fancy way, right? So we're just using what they gave us to answer questions. Let's go ahead and do that now. We have a survey here, and it says that 50 students, which means when we add these up, our total is 50. And it says, which of these statements are true? So take a look at the first one. What do you guys think? Do you think that 25% prefer chocolate based on this experimental probability? Go ahead and pause the video now and see if you guys think that's true. So let's see, 25%. Let's go ahead and take our information over here and see if this is true. So how many prefer chocolate? So we take the desired, or what they're asking us about, which is chocolate. We put chocolate on top, total on bottom. And the question is that 25%? And of course, 25 is out of 100. So take a look at that. Does that look like that makes sense? And the answer is no. 25 over 50 is not the same as 25 over 100. That doesn't work. Another way we could have checked this is we could have cross multiplied, and we see that 100 times 25 is 2,500 or 2,500. That will not equal 50 times 25, obviously. Okay, that would be half of that. Another way we could have done that is we could have just taken these two and said 25 out of 100 means 25 over 100. And just like we figure out our grades on a test, right? We take the total number that we got right out of the total number possible. Sorry, I'm trying to write my best with this. Out of the total number we got possible, and we just divide those two, right? In and out, take our calculators. This division this equals, convert that decimal to a percent, move it 2 times, and we don't get 25% no matter how we do this. So, long story short, A cannot be true. Let's check B now. You guys go ahead and read B. Pause the video right now and try it on your own first. So let's see. The question says, if there was 200 people, would 100 prefer chocolate? So again, we're going to take our information over here that they gave us from the experimental probability, right? And we're going to go ahead and say if we had 100 chocolate out of 200 total, would that be the same, or would that equal, or would that be proportional to what we have in the table? Well, the table has 25 chocolate out of 50 total. And some of you can look at that right away and say, yeah, it's the same. Whoops, I put 500, didn't I? Take that 0 off there. Sorry about that. So 100 is half of 200. That means 25 is half of 50. Of course, these are proportional to or equal to, right? All right, another option is we could have cross multiplied. 50 times 100 is 50 with 2 zeros, or 5,000. 25 times 200 is 2 times 25, like 2 quarters, right? Which is 50 with 2 zeros, which is again 5,000. So it works either way, okay? If you wanted to do it this way, where you said, well, 100 out of 200, convert that to a percent, that's 50%, right? Of course, that would have worked, where 25 is 50% of 50. So either one of those ways you guys want to do it is fine. I'm probably going to stick with one way just so I don't lose some of you guys. I'll probably just stick with proportions for the rest of this lesson. All right, so let's go ahead and go to the next one. We're going to use experimental probability to predict if these results are true. Pause the video, try this now on your own. So let's go ahead and take a look here. We see that it says 2.5 times as many students prefer chocolate as vanilla. So if I have 2.5 times as many, let's say vanilla was 1. If vanilla was 1, then this is 2.5 times as many. 1 times 2.5 would be 2.5, wouldn't it? So I have 2.5 for every 1 vanilla. Is that proportional to what we have over here? Again, I put chocolate on top. I got 25 chocolates from the table. And vanilla, I have 10. This time I'm not using the total, right? I'm using vanilla. And the question is, do these two equal each other? Are these two proportional? Well, if I cross multiplied for all proportions, this is true. This times this has to equal this times this. And is that true? Well, 2.5 times 10. You remember we multiply by 10. The shortcut is move the decimal one time, right? That would be 25. And 1 times 25 is 25. Since that is true, that means this statement is true also. So right now we know that A didn't work, B worked, and C worked. Let's check one last one. Let me clear this out here. Okay, looking at the next one. You guys go ahead and pause the video now and read this question. So let's see. D says, if 20 students prefer mint, so I have 20 mint. 21 would prefer strawberry, so that means I have 21 strawberry. So, is this true? Let's check our table. Compared to our table, we have, the table has 7 mint. And how many strawberry? 8 strawberry. Now, at a glance, this looks like it works, doesn't it? It looks like it's true because this is one more than this, and this is one more than this. And we know that in proportions, we have a relationship, right? Going from top to bottom like that. But the relationship has to do with factors or multiplying. So in other words, I know that 4/8 is the same as 1/2, right? Because 4 is half of 8 and 1 is half of 2. So look at the relationship. If this is 2 times bigger, this is also 2 times bigger. But notice that I said 2 times bigger. Times means factor. Factor means multiply. It's not addition. So think about it. If you guys ever had a test where there was 2 questions and you got one right, you know you got 50%, right? But what if you had a test and there was 10 questions and you got 9 right? They both have a difference of 1, but clearly 50% is not the same as a 90% test, right? So as these denominators change, the difference between these means something different. So if everything I'm saying right now is confusing to you, then this is how you do it, the same way we did the other ones, right? And we're just going to stick with one way, even though there's a few ways we can answer these questions. We're just going to stick with setting up a proportion and see if our means equals our extremes, if when I cross multiply, if they equal each other. So does 20 times 8, which is 160, equals 21 times 7. If you can't do this mental math in your head, don't feel bad. Just pull up a calculator. 21 times 7 is 147. I can see that these are not equal to each other. Therefore, this is not true. So for this problem, B and C were correct. So on your quiz next week, if you guys get a question like this, and you might get this question or one of the next two, we'll have to see. Make sure you choose all that are correct when the directions ask you to do so. So most of our quiz questions will be multiple choice, but some of them will be pick all of the correct answer, right? You have to check all that apply. Let's go ahead and start our next problem now. I want you guys to pause the video, take 5 minutes, and try this problem on your own before I teach it to you. So it says we have an experiment here. Someone actually did this experiment, gave us some results, and we're going to see which of these statements down here were true based on what's called look at this new vocabulary word here, observed frequency. So observed frequency means just like this problem over here. We did some experimental probability, and what we got was our observed frequency. So let's know that word, observed frequency. So our observed frequency gave us this information down here. We learned that there's twice as many reds as blues, and 1/5 of the marbles were orange. So that was our observed frequency. So the question is, which of these down here match this information? Okay, well, let's see. 3 of these are wrong, 1 is right. So to answer this question, when you guys see this on your quiz next week, it's going to be like this. We want to see which of these down here have about, it doesn't have to be perfect, but about twice as many reds as blues. So let's look at these 4. Which of these 4 look like they have close to twice as many reds as blue. Now listen to how I'm saying twice as many reds. So reds is the big one, right? Let's not get those switched. So we can look at the blues and see if I multiply by 2, do I get about what I have for reds? Let's check A. So for blue, if I double that, I'd get 22 for blue. Look at the reds. Is that about 22? Pretty close. It could be A, because there's about twice as many reds as there are blues. Okay, so far we know it could be A, maybe A. Let's take a look at B. Take a look at the blues, take a look at the reds. Well, you know what? There are less reds than blues. So I know that can't be true, because there has to be about twice as many reds as blues. So let's go ahead and forget that. Take a look at C. C says there's 30 blues, 16 reds, can't be C. Take a look at D. 22 blues, 45 reds, that's about twice as many, right? If I doubled 22, I'd get 44. That's around 44, so already I know it has to be A or D. I already got a 50-50 chance just by looking at the first one. Let me go ahead and turn off my phone here since it's going off while I'm trying to make a video. All right, so let's go ahead and take a look at the next one now. The next one says 1/5 of the marbles chosen, it says were orange. Power off. There we go. So we're only looking at A and D, right? We're not worried about B and C because those can't work because of the first set of rules or first stipulation. So it says 1/5 of the marbles chosen were orange. Let's take a look. So for A, is 21 oranges about 1/5 of the whole thing? Remember, the whole thing is out of 100. So if I have 21 out of 100, is that about 1/5? Well, let's see. Let's stick with the same way. Let's stick with proportions again. Okay. Let's see if 1/5 is about 21 hundredths. Are they pretty close? Let me see. 1 times 100 is 100. And 5 times 21 would be 105. That's pretty close. So the answer is probably A. But let's check D just to make sure. So for D, if there are 5... This tablet is so hard to write with. So if there are 5 oranges, okay, 5 out of 100, is that about 1/5? Well, if I cross multiplied, 1 times 100 is not about 20. That's not even close, so forget about that. Answer has to be A. And last problem for our lesson. We got a short lesson today. You guys go ahead and pause the video, read this now, give it a good 5 minutes on your own first. Let me go ahead and scroll down here so you guys can see the entire table. I'm sorry about that. Some confusion there, okay? So let me see if I can take this here and change my view so you guys can see the whole table better. Let's get the entire page in there. Okay, so I'm actually going to read this to you and then I'll have you pause it, okay? So, first of all, there's a total of 515 students. 515 students. Okay. Now I can go ahead and zoom this back in. I'll go, let's see, gotta work with it here. So I'm gonna scroll this down now, and you guys are gonna take a look at this table and this total and see which of these, select all that apply, are true. Now pause the video and try it. All right, so let's take a look. It says the first statement is about 175 students spend their time eating dinner. Okay, so let's see. Look at our, what do they call that again? You guys remember what that new word was? Let's look at our observed frequency from our experimental probability to see if that statement is true, to predict whether that's true or not. So let me see here. We're talking about eating dinner, so we'll look at the eating dinner section, and it says 34%. We're talking about 34% of, now percent is out of 100, so we use percent proportion when we deal with percents, right? So remember, we can use proportions to solve all these questions. So I'll use percent proportions since they talk about percents. 34% of 100. Then would it be true that 175 would eat dinner? So we have 34% of 100. That means 30%, 34% spend time eating dinner out of a total of 100%. And for this problem over here, the question is that the same as 175 over 515? So again, I can just cross multiply and see if we get the same thing. Okay, so let's go ahead and use the same method we've been doing for all these questions, see if that works out. So 175 times 100 is 175 with two zeros, which is 17,500. Question is that the same as 515 times 34? So I go 515 in my calculator times 34, and I get 17,510. 17,510. That's pretty close. It says about. That's really close. If it's that close out of tens of thousands and it's that close, I would tend to say, yeah, that seems true to me. Okay. Now, if it said exactly, I would say no. But since they said about, that's pretty close. Now, some of you are thinking, Mr. Carbajal, there's an easier way to do this. Yes, if they give you 34%, you guys simply could have done, yeah, you could have converted 34 times 515, and you could have got that answer right there. But you got to convert percent to a decimal first, multiply, and we would get about 175.1. Yeah, that's basically the same thing, isn't it? Okay, so let's check the next one now. So we know that A works because it says about and it was close enough. How about the next one? Is 72 would about 72 students spend time playing sports? So we look at sports. They're asking about sports, so I look at sports. 14%. 14% means 14% out of 100. What was our total? It goes percent over total, percent over 100. What would that be out of 515 people? Cross multiply, okay, to see if that's true. Or since our way of doing all these is just to set up a proportion, we can set that number there. We'll see if 72 works. 72, is it about 72? Let me see, 72 times 100 is 7,200. And 515 times 14, let's see what we get there. 515 times 14, and we get 7,210. That's pretty close too. That's pretty close too. That worked out. Let's go ahead and check the next one now. The next one, let's use this, what do we call it? Remember that word? Observed frequency over here, and see if this is true. Is it true that about 50 students will be watching TV? So we'll look at our information down here. We go to where it says watching TV. We see that 20% said that they were watching TV. So if it is 20%, that's 20 out of 100. Will that be proportional to 50 out of 515? Because 50 are watching TV and 515 was the total. They gave it that to us, remember up here, beginning of the problem, 515 up here. Okay, so I have TV over total, percent over 100, TV over total, 50 over 515. Is this proportional? Is this equal to this? Well, all we got to do to answer that question is to simply cross multiply. 50 times 100 is 50 with two zeros. 1, 2, or 5,000. And 515 times 20. Take our calculator, clear out our last problem. I go 515 times 20. And I get 10,030. 10,030. I don't think, was it 30 or 300? Let me check that. 10,300. 10,300. Well, either way, 10,300 or 10,030, neither one of those is close to 5,000. So I would say no. This one's not true. Don't check this one. Don't select that, right? That's wrong. So let's check our last one now. Let's check our last one. It says about 38 students spend time with their family taking walks. So 38 students, that's 38 out of a total of 515. Let's go down to our, you guys know that word already? You got it memorized? Let's check our observed frequency from our experimental probability and see if that is proportional to this ratio of, remember they're asking about taking walks, so I find the one that says taking walks. Taking walks right there. Okay, 4%. And 4% means out of 100. So are these the same about? Again, we cross multiply 38 times 100 is 38 with two zeros, or 3,800. 515 times 4. So we get on the other side. Let's go ahead and take our calculator right now and check that. Clear out your calculator. Go 515 times 4, and 2060 is what we get. 2060, I would not say is close enough to 3,800 to say that works. So it looks like only the first two were true based on our experimental probability. So the first two you should have checked for this problem. All right, so that's it for our lesson today. We will see you guys in a couple days.